is M.K. Chakravarti. Today we are going to learn some important concepts in chapter motion. This is very useful for 9th class students and also 8th class students who are going to IIT foundation course. Speed is the most common measurement used to describe the motion of objects. Saying a race car or a plane is fast is not enough to accurately describe its speed. In this section, you will learn a precise definition of speed. Once you know an object's speed, you can figure out how far it can go in a certain amount of time, or you can predict how long it will take to get somewhere. So you need to understand these vocabulary. Speed, the distance an object travels divided by the time it takes. The constant speed, speed of an object that travels the same distance each second. Here we need to define the concept speed. Speed is defined as the rate at which a particle covers a distance along a given path. It is given by the ratio of distance traveled to the time taken. The formula to denote speed is distance traveled by time taken. Speed is equal to s by t. Here in this diagram, imagine two cars moving along the road at different speeds. The picture below shows the position of each at 1 second intervals. The fast car moves 3 times the speed of the slow one. The fast car moves 3 meters each second with constant speed, while the second car is rest relative to first car. Here we need to understand constant speed. Speed of an object that travels the same distance each second. In this situation, imagine two cars moving along the road at same speeds. The picture below shows the position of each car at 1 second interval. The both cars moving 10 meters each second with constant speed. Here again we need to understand constant speed. What is meant by constant speed? Speed of an object that travels the same distance each second. We know that the speed is distance divided by time. We can apply the speed definition to the particular example. The speed of a car is the distance it travels divided by the time it takes. At 10 meters by second, the second car travels 10 meters each second, while at 30 meters per second, the first car travels 30 meters each second. Both cars in the diagram are moving at constant speed. Constant speed means the same distance is traveled every second. The snapshots are very evenly spaced, so you know the distance traveled by each car is the same each second. To find the actual speed at any instant, we would need to know the distance moved in a very short interval of time. This can be done by multi-flash photography. In this figure, the golfer is photographed while a flashing lamp illuminates him 100 times a second. The speed of the club head as it hits the ball is about 200 km per hour. Imagine how much speed he hitting the ball. So this tells about a new concept, instantaneous speed. The speed of a particle at a given instant is known as instantaneous speed. The speedometer of a vehicle indicates the instantaneous speed of the vehicle. Here you note these certain points. Since distance traveled is a scalar, the speed of a particle is also a scalar. Recall previous knowledge about scalars. They have only magnitude, and addition or subtraction of scalar quantities can be done by simple arithmetical means. Similarly, we know that vectors, both magnitude and direction, are needed to define vectors. Special vector addition rules are needed for adding or subtracting vectors. Here another note is the unit of speed is centimeter per second or centimeter second inverse in the CGS system, and meter per second or meter second inverse in MKS system or SI system. Now the next concept is average speed. In this section, you will learn a precise definition of average speed. Once you know an object's average speed, you can figure out how far it can go in a certain amount of time, or you can predict how long it will take to get somewhere. Look at this example. If a train travels 720 kilometers from Hyderabad to Visakhapatnam, let us assume that in 12 hours, its average speed is 720 kilometers by 12 hours. That is equal to 60 kilometers per hour. Actually, the speedometer would certainly not reach 60 kilometers per hour for the whole journey, but might vary considerably from this value. That is why we state the average speed. If a train could travel at a constant speed of 60 kilometers per hour for 12 hours, the distance covered would still be 720 kilometers. It always true that average speed is equal to distance moved by time taken. Here is another concept is there, average velocity. What is meant by average velocity? It depends on the displacement of an object per unit time. The displacement on object per unit time is called average velocity. Average velocity is a vector. It is a vector physical quantity and is along the direction of the displacement. That's why we can define average velocity like that, and the formula to find average velocity is equal to displacement by time taken. Look at the example. Let the displacement of the trip in the above example be 360 kilometers due southwest. What is the displacement in each hour of the train? The displacement per hour is equal to 360 per 12 hours southwest. That gives the value 30 kilometers per hour southwest. So that we can define average velocity is equal to displacement by time taken. Thank you, students. We will learn next concept soon. Thank you.